Welcome back again in this session. In this session, we are going to start a discussion on limit state of collapse in shear. Up to now, we have discussed about the limit state of collapse in flexure. In that one part, we have discussed that is design of a singly reinforced section. We have discussed and we have solved some numericals also up to last session. Okay, we have solved the analytical types of numericals as well as we have solved some design types of numericals on the design of singly reinforced section. So I think there is no doubt from your side. If you have, then please let me know just right now. If any doubt on the design of singly reinforced section, काही शंका असेल तर आत्ताच विचारा. नसेल तर मग आपण पुढचा पार्ट चालू करू डिझाइन ऑफ members in case of shear. That is limit state of collapse in shear. काही शंका आहे का मागच्या पार्टवर?
No, sir.
Okay, good. So we'll move to the next point, that is limit state of collapse in shear. So as we know that the beams or the flexural members which we are going to discuss here, these beams whenever subjected to external load, flexural action is going to develop. Flexural action means that the beam is going to deform and then due to the deformation, some part of the beam is going to subject to the compressive stresses and some part of the beam will be subjected to tensile stress. Okay. And which develops the bending moment. And as we know that suppose if we take an example of a simply supported beam, so if this beam is subjected to external load, then what happens that if we draw a bending moment diagram, then the nature of that bending moment diagram will be like this. Okay. So that bending moment will be maximum at the midspan and it will be zero at the support. If we consider the fixed support given, then what will be the bending moment diagram for fixed support? Hmm? Fixed support साठी bending moment diagram कशी असेल?
Same असेल sir अशीच.
Same असेल. There is slight change in this side diagram. काय फरक असतो जोडणार आहोत? सर्वोदय चेतन शिंदे
हा सर
काय फरक असतो फिक्स्ड सपोर्ट जर असेल instead of simply supported beam, let us consider that this beam is fixed supported at the both ends and it is subjected to uniformly distributed load. So the bending moment diagram will be similar to this, or is there any change? Okay. So just we will get like time nap. What happens that due to the fixity at this support and at this support, some moment is going to develop at this support. Okay. So this moment will be there and the bending moment diagram will be like this. Okay. Parabolic one. Okay. So this moment we call at the positive moment and the moment which is going to develop at the support will be termed as a support moment which is negative. Okay. So normally this kind of conditions will occur in any case of beams what we are providing actually in practice, because in actual practice, particularly in case of RCC structures, that whatever beams that we are constructing, these beams are monolithically constructed. So that's why these beams not act as a simply supported beam. Okay, so there is a partial fixity, so due to that some moment will be there. But that is not part of our discussion right now. So just we know, we must know that this is the variation in the bending moment. So at one end the bending moment is maximum, at other end the bending moment will be minimum or zero. Due to this variation, what happens that if you take the section at this particular instant, then you will find that the intensity of bending moment will be different. If you take the section at midspan, then the intensity will be different. Again, if you take a section at this location, then the intensity will be different. So this is the variation in the bending moment. And due to this variation, what happens that there will be a development or generation of shear stress in that particular beam. Okay, this that shear in beam is caused due to the change in bending moment in the span, and for a beam of homogeneous metal means what? What do you mean by homogeneous metal?
Mixture of two or more materials.
A mixture of
Two or more.
More
no,
than two
that is
materials.
more. That is not called as a homogeneous. That is exactly opposite to the homogeneous. Homogeneous means it is made up of only single
Same.
material. Okay, single material. Hmm? And a mixture of two or more metal will be called as a composite section. ठीक आहे लक्षात घ्या दोन्ही एक्झॅक्टली अपोजिट सांगितलं तुम्ही homogeneous means
Okay, sir.
if you construct the beam of plain cement concrete only, then we call that particular material as a homogeneous metal. But if we put steel in that, then that will be called as a composite metal. Yeah, because we have used concrete as well as steel in a single section. So that is called as a composite section. Okay. But in case of for a beam of homogeneous metal, the shear stress at any section will be given by this equation. Okay, this is the equation, and the symbol tau is normally adopted for representing shear stress. Okay, and V is used to denote the shear force. Okay, so you can calculate the shear stress at any location or at any section of a beam which is made up of plain or single metal, that is homogeneous metal, then we can calculate the shear stress by using this equation where this V is the shear force at any section, Ay is the moment of area above the section, about the neutral axis, just you can see the figure here. Then B is the width of the section or the breadth of the section, and I is the moment of inertia of the section about neutral axis. Okay. Now what is this? How this equation is derived? So for that, this equation already you have studied in your previous subjects. Okay. So just you have to remind back and go to the SOM, or I think ISM is the subject for you. Okay. So the distribution of shear stress across the homogeneous beam rectangular section is shown here in this figure. It is a this shear stress will vary throughout the section or throughout the depth of the beam like this, as shown in this figure. So maximum shear stress will be at the neutral axis, and it goes on reducing up to the top fibers and bottom fiber, that is tension and compression fiber. Okay, it is the shear stress distribution across the beam section at any one beam section, any section. Okay. I'm not discussing, I'm not saying that shear force distribution. It is shear stress distribution across any section taken at any location of that beam. Okay. So this variation of shear stress is a parabolic one for homogeneous material. Okay, for homogeneous material. Huh?
स्टुडंट्सला ऍड करायचं.
ठीक आहे. Okay, so at any section, the shear stress distribution will be like this, which is having a parabolic nature. Now, as I told you that the shear stress distribution will be maximum at the neutral axis and zero at the bottom and top face of this section. But as in case of reinforced concrete section, because the reinforced concrete section is a composite section, which is made up of concrete as well as steel. And we have provided the steel in the tension zone because as we know that this concrete is not able to carry the tensile forces, so that's why whatever tensile forces are going to develop in that section are to be taken care by the steel. And by considering this, we have provided, normally we are providing the steel at the tension zone. Okay. So that in case of a reinforced concrete beam, the concrete below the neutral axis is neglected. Concrete below the neutral axis is neglected means already we have discussed in case of singly reinforced section that if you take a concrete section, then the part above this neutral axis will be subjected to compressive stresses, below neutral axis will be subjected to tensile stresses. Concrete is weak to carry the tensile stresses, so whatever concrete present here, that is of no use actually. But to carry these tensile stresses, what we are going to provide, we are providing the reinforcement here. Okay. So this concrete which is present here is not going to take any amount of tensile stress, as per the assumption that tensile stress in concrete is neglected. Okay, so that's why we are writing this statement. But the shear is assumed to be resisted by the bond between the concrete and steel in this particular area. Whatever shear which is going to develop, because actually for the plain cement concrete which we have discussed before, suppose if this section is of plain cement concrete, only concrete is used here, then the shear stress distribution will be like this parabolic one. But actually here what happens in case of reinforced concrete beam, we are providing the reinforcement here. Okay, so this concrete is not going to take any tension. So all the tensile forces will be taken care by this reinforcement. Okay, so that's why the shear stress distribution in this particular reinforced concrete section will not be similar to this. Hmm. This kind of shear stress distribution will not occur in case of reinforced cement concrete. So the distribution of shear stress across the section will be like this, as you can see in the figure, that the shear stress in RC beam varies parabolically with the value 0 at the compression phase and reaches maximum to the at the neutral axis, and then it becomes constant and constant varies constantly and reaches to the 0 abruptly at the CG of this reinforcement what we have provided. Okay. So this is the shear stress distribution, hmm, which is already we have discussed. Hmm. But we have discussed the stress distribution. This is the shear stress distribution diagram. Okay. So by using this figure, uh, again I know that you are listening these all points, but this may be for the some of you that this may be the difficult one to understand at the single time, at a single time. एकदाच ऐकल्यानंतर किंवा एकदाच वाचल्यानंतर लक्षात येणार नाही कारण का थोडा मागचा रेफरन्स पण घ्यायला लागणार आहे. Okay, so this is the shear stress distribution for a reinforced cement concrete beam. Okay. So this is the derivation. Actually, I am not going to explain this in detail. That if you draw, if you want means that whatever that equation that we have seen that tau is equals to b a y bar upon, so that how the equation is derived. So for that you have to consider this diagram. Okay. So here again, as we know that stress is equals to force into area. Okay. So this same concept we are going to here. So shear force we want to calculate. So shear force will be equals to area of straight diagram into the width of the beam. So if we plot that, if we put the values here, area of straight diagram means it is again combination of rectangle and parabola. So if you draw that, then you can easily calculate this equation, that is tau is equals to V upon V into Z. Okay, so this equation we are going to use in further discussion also. So that is how we have derived this equation. So this equation, just why I am writing this equation here, because you have to use this equation as specified by IS 456 also. Okay, so if you open IS 456, then in IS 456 there is one clause. What is that clause? Just we'll discuss. So that the behavior of concrete is very complicated, and hence it has not been possible to determine the exact shear stress distribution across the section. मी सांगितलं की this is the generalized statement what I have made there, that shear stress distribution in concrete is a parabolic one, or when you provide the reinforced concrete, then the shear stress distribution will be just a combination of parabola and rectangle. But that is not always possible, or we cannot exactly find out the shear stress distribution in the concrete section because of number of variations in the materials properties and the conditions also. So by considering this, the designer is only interested to know the shear resisting capacity of the section rather than the actual shear stress distribution. So being as a designer, म्हणजे ॲज अ डिझायनर म्हणून आपला इंटरेस्ट कशात असायला पाहिजे की बाबा ना एखादा जो सेक्शन आपण डिझाईन करणार आहे तर तो सेक्शन मॅक्सिमम किती शिअर स्ट्रेस कॅरी करू शकतो. दॅट इज द थिंग दॅट ॲज अ डिझायनर वी मस्ट consider, rather than means there is no need to consider, or no need means that there is no interest to consider that how this shear stress is going to vary. शिअर स्ट्रेस कसा व्हॅरी होतो, काय होतं, ह्याच्यात आपल्याला जास्त इंटरेस्ट असायला नाही पाहिजे. फक्त आपल्याला एवढंच माहित असायला पाहिजे ॲज अ डिझायनर की एखादा सेक्शन जो काय मी डिझाईन करतो, त्याची विड्थ काय तुम्ही डिसाईड केली, डेप्थ काय डिसाईड केली, तो सेक्शन किती जास्तीत जास्त शिअर फोर्स कॅरी करू शकतो. That is our prime intention. Okay, and that's why the simple concept of nominal shear stress has been introduced in IS 456/2000 as per the clause number 40.1 on page number 72. So I'm again requesting to all of you that open this page number 72 and open the clause number 40.1. Go to this clause and just any one of you just read that clause. Page number 72. Telugu page number 72. Rahul Chavan.
Yes, sir.
Page number 72 open केलं का? IS 446.
हो सर केले.
वाचा clause number 40.1 काय दिले याच्यात सांगा.
The nominal shear stress in beams of uniform depth shall be obtained by the following equation. Tau phi is equal to Pu divided by Bd.
That as per this clause number 40.1, what is that? The nominal shear stress in beam of uniform depth shall be obtained by following equation. Now just look at this equation. Tau V. and the equation what we have seen here in this previous slide. काय सेम आहे का थोडंफार? Tau is equals to V upon Bz, and here tau is equals to Vu upon Bd. What is meaning of Z here? Here the Z means the lever arm. Normally it is d minus x by 3. So instead of this, we have taken here V into d. That is effective section. What is V? V?
Width of
V here, VV, I'm asking V. Or here in case of this equation, clause number 40.1, clause number 40.1, VU is the design shear force or the shear force due to the design load. V is the width of section and D is the effective depth of section. So B into D is the effective cross-sectional area of the section. Effective cross-sectional area of the section. And Vu is the design shear force. So force per unit area gives you the stress, shear stress here, tau V. Okay, so this is called as the nominal shear stress, or the shear stress which is going to generate due to the application of this shear force over an area of B into D. Okay, so this much shear stress will be developed in that B. So now we have to know that what is this shear stress, and for this then we need to do that, means to avoid shear kind of failures. To avoid shear failures, we have to provide a sufficient depth or we have to provide the sufficient reinforcement. That is nothing but the shear design. So we'll discuss about the shear design. So firstly, we must know that what is the nominal shear stress. So this is the simple concept given here. Nominal shear stress, tau V is equals to Vu upon Vt. So this term you have to remember. Again, IS 456 will be allowed in the exams when you are going to give this exam as a in an offline mode. But again, that is not possible as in current situations. So you have to go for the objectives on this kind of questions. So equation विचारू शकतील तुम्हाला any term एखादी term cancel करून किंवा in the words also. So you must be able to define that what is the meaning of nominal shear stress. Nominal shear stress is the shear stress developed due to the application of shear force, design shear force over an effective cross-sectional area of the beam. Okay, so that is called as a nominal shear stress, which is going to develop in that section due to the application of external forces. Due to the application of external forces, some shear force is going to develop, and due to that shear force, a stress will going to develop across the beam, and that stress must be resisted by that concrete. Or concrete should be in capacity to carry that much amount of stress. So for that again we must need that what is the shear resisting capacity of the concrete section. Okay. We must be able to know that what is the shear resisting capacity of the concrete section. So that we'll discuss here. But before that again let us consider one more concept. That some terms we'll discuss here, that Vu is the design shear force or the shear force due to the design load. B is the width of the member, which is here, which for flange section shall be taken as breadth of the web, BW, and breadth of the member, which for flange section shall be taken as the breadth of the web, BW. Now what is meaning of this? What is the meaning of flange sections? So just here you can see that these two sections are called as the flange sections. This is T beam. This first one is the T beam, and this second one is the L beam. L beam. So this kind of sections will be formed at the intermediate part or at the end of continuous slab. Okay. So this part will be of slab. This part will be of slab. Okay. So some means here there will be a continuous slab on this side as well as on this side. So some part of this slab and beam which is supporting to this slab will form a T beam, and at the end slab means suppose again here there is a slab in continuity, and this is the end beam, so this will form a L beam. So this L beam or T beam is having two sections or two parts. That this top part, this top extended portion is called as a flange. This one and this one, and this portion will be called as a web. So as all of you know that in case of steel sections, you have discussed about this. So this is also web and this is a flange. So whenever in case of flange sections, this width we have to consider as a width of the member, BW, that is width of web. In case of rectangular section like this, we are going to consider this as the width of section B. Okay, so this thing you have to remember all the times. And the design shear force VU you can easily obtain depending upon the supporting conditions. Okay, so for a simply supported beam, the VU will be equals to WL by 2. Just you have to calculate the support reactions. And this shear force variation will be like this. Okay, linear variation will be there, maximum at supports and zero at the midpoint. Okay, so this is the shear force variation in the beam. Shear force variation, I'm saying that, remember that I'm saying that shear force variation along the span of the beam. ठीक आहे, इथं पण काय अडचण, काय शंका येतोपर्यंत? ठीक आहे, त्यातलं परत क्लास नंबर 40.1.1 काय सांगू शकतं का मला कोण? आनंद कोणे? आनंद आनंद कोणे? सुटला बरं का मी, सपना लवंड. पद्धत
हा
गिट्टे.
सर.
हा, क्लॉज पुढचा क्लॉज नंबर वाचायचा जरा, क्लॉज नंबर 40.1.1. असा आज 4.6 ओपन करून बसा म्हणून सांगितलं मी.
कुठला 40 पॉइंट
1.1 पेज नंबर 72.
beams of varying depth. In the case of beams of varying depth, the equation shall be modified as क्लिअर दिसेना सर,
काय
फॉर्म्युला आहे तो.
प्रिंटआउट काढलं नाही का आज 4.6 ची?
नाही, मोबाईल मध्ये.
मग मोबाईल मध्ये झूम करायचं, त्याला झूम होते की.
Tau V is equal to Vu plus minus mu divided by D tan B divided by B into D.
Tan beta.
Sorry, tan beta.
Okay, so this is the equation. Now it is available in on your screen. So screen वर बघा. That in case of beams with varying depth. Now the varying depth म्हणजे काय? की फॉर एक्झाम्पल आपल्याला माहिती आहे की कॅन्टिलीवर बीम आपण प्रोव्हाइड करतो. कॅन्टिलीवर बीम म्हणजे असा कॅन्टिलीवर बीम जर तुम्ही डिझाईन केला विच इज सब्जेक्टेड टू यूडीएल, देन वी नो दॅट मॅक्सिमम बेंडिंग मोमेंट विल ऑकर ॲट विच सेक्शन ऑर विच पार्ट ऑफ दिस बीम. कॅन्टिलीवरला मॅक्सिमम बेंडिंग मोमेंट कुठे असेल? परत परत तेच सांगायला लावू नका. बऱ्याच वेळ झालंय आपण याच्यावर डिझाईन केलं आपण. हा, योसना राऊत कोळी नितीन, हुसेन मुलानी, अंकिता गाडगे,
येस सर.
सांगा की कॅन्टिलिव्हर साठी मॅक्सिमम बेंडिंग मोमेंट कुठे असेल? बेसिक क्वेश्चन का कुठल्याही इंटरव्ह्यूला ज्यावेळेला जाल तुम्ही त्यावेळेला तुम्हाला शिअर फोर्स बेंडिंग मोमेंट डायग्राम विचारणारच आहेत. कुठल्याही इंटरव्ह्यूला जाल म्हणते मी, कुठल्याही.
राईट जॉईंटला असणार आहे.
मॅक्सिमम बेंडिंग मोमेंट विल ऑकर ॲट सपोर्ट का जॉईंट?
जॉईंट.
फिक्स्ड एंडला सर.
फिक्स्ड एंड.
ओके. किती असेल मोमेंट ते? मोमेंट किती असेल? फॉर एक्झाम्पल हे स्पॅन जर याला असेल आणि लोड डब्ल्यू असेल तर परवा सॉल्व्ह केलं ना, परवा प्रॉब्लेम दिलता ना एक होम असाइनमेंट साठी.
डब्ल्यू
कसं लगेच कसं काय विसरता मला कळत नाही. परवा तो सॉल्व्ह केला ना प्रॉब्लेम. So this bending moment will be like this. Parabolic profile असणार आहे, मॅक्सिमम ऍट सपोर्ट अँड 0 ऍट द फ्री एंड. ठीक आहे. आता मग मला सांगा, आपण डिझाईन ऑफ सिंगल इन्फोसेक्शन केलेलं आहे पहिला, ह्याच्या आधी जस्ट. इथं बेंडिंग मोमेंट 0 आहे एंडला, फ्री एंडला. सो व्हॉट इज द रिक्वायर्ड डेप्थ? व्हॉट विल बी द रिक्वायर्ड डेप्थ ऍट फ्री एंड? फ्री एंडला डेप्थ किती पाहिजे? बोला बोला, पटपट बोलायचं, ते जास्त वेळ लावू नका. हॅलो, इक्वेशन काय तर केलते की तुम्ही? एमयू लिमिटिंग इज इक्वल्स टू काय तर म्हणला त्याला, काय कुठलेही घ्या एखादे एक्झाम्पल, ग्रेड 0.138 FCK BD स्क्वेअर, काय तर केलं नसलं विसरलं लगेच. आता हे मोमेंटच 0 आहे म्हटल्यावर मला डेप्थ किती लागणार आहे सांगा? Simple आहे की t will be equals to 0. Theoretically, there is no need to provide any depth at this section, and the maximum depth you have to provide at the support. म्हणूनच कॅन्टिलिव्हर सेक्शन जर तुम्ही काही वेळेला कुठं तर बघितलं असाल प्रॅक्टिकल मध्ये, त्यावेळेला ते कॅन्टिलिव्हर सेक्शन असे प्रोव्हाइड केले असतात. काय काय असतात का? बघितलं का कधी? बघितलं का? ठीक आहे. दॅट द मॅक्सिमम डेप्थ वी हॅव प्रोव्हाइडेड हिअर. हे असं पण प्रोव्हाइड करू शकतो आपण, नो प्रॉब्लेम. युनिफॉर्म डेप्थला लहान असेल तर असे केलेले दिसतील तुम्हाला. बट अगेन दिस व्हॉट एव्हर कॉन्क्रीट दॅट यू आर गोइंग टू प्रोव्हाइड हिअर विच इज ऑफ नो यूज, याचं काय गरज नाहीये. ठीक आहे, ही गरज नसताना तुम्ही इथे प्रोव्हाइड करताय. सो दिस विल बी अनइकॉनॉमिकल. सो समटाइम्स दिस पार्ट वी आर रिमूव्हिंग. ओके, अँड वी मे प्रोव्हाइड द सेक्शन्स लाईक दिस. पर्टिक्युलरली लॉंग स्पॅन सेक्शन जर असतील तर तुम्हाला असे बघायला मिळतील. एक्झाम्पल जर तुम्ही बघितलं तर स्टेडियम वगैरे जर कुठं असतील तर स्टेडियम मध्ये असे कॅन्टिलिव्हर्स काय काय ठिकाणी बघायला मिळतात, किंवा जर तुम्ही थिएटरच्या बाल्कनीमध्ये बघितलं तर ते असे दिसतात. ओके, सो दिस इज द सेक्शन. आता हे सेक्शनला आपण म्हणतो बीम्स विथ वॅरिंग डेप्थ. वॅरिंग डेप्थ का? तर इथं जर बघितलं तर डी वेगळा आहे, इथं मध्ये केला तर अजून थोडा कमी झाला आणि एंडला अजून थोडा कमी झाला. सो दिस डेप्थ इज वॅरिंग. ओके, सो दिस काइंड ऑफ सेक्शन्स आर कॉल्ड एज अ बीम्स विथ वॅरिंग डेप्थ. ओके, मग वॅरिंग डेप्थ असेल तर तुम्हाला शिअर फोर्स किंवा शिअर स्ट्रेस कॅल्क्युलेट करताना हे इक्वेशन वापरायचं आहे. ओके, VU plus minus MU upon D into tan beta divided by B into D. Okay, now what is this beta? So beta is nothing but this angle between this inclined plane and the horizontal. This angle is called as a beta. As an example मी पुढे सांगतो पुढच्या पेजवर. Okay, tau V is the nominal design shear stress, VU is the design shear force, MU is the design moment, D is the effective depth, V is the width of the section, and beta is this angle. Okay, so these are the terminologies which we have used here. So here in this IS 456, they have given this notification that the negative sign in the formula, the negative sign in the formula applies when, कारण इथं प्लस मायनस हे दोन साईन वापरत ना, मग त्यातलं निगेटिव्ह कधी घ्यायचं आणि पॉझिटिव्ह कधी घ्यायचं. सो दिस निगेटिव्ह साइन can be used when the bending moment mu increases numerically in the same direction as effective depth d increases, and the positive sign when the moment decreases numerically in this direction. म्हणजे काय, तर परत हेच कॅन्टिलिव्हरचे एक्झाम्पल घेऊ आपण इकडे बघू. ठीक आहे, टाइम आहे आपलं लेक्चरचं 10. लोक जॉईन होतात 10:53. सौरभ सावंत. ठीक आहे, सो ॲज आय एम रायटिंग दिस इक्वेशन अगेन हिअर, that the negative sign in the formula applies when bending moment mu increases numerically in the same direction as the effective depth d increases. Example काय परत, I am taking example of a cantilever section which is subjected to some external load. The depth of this concrete section at the support is d and the depth at free end is d dash. Okay, so it is reducing at up to the free end, maximum at support and minimum at free end. Now this is subjected to external loading W, and due to this what happens that bending moment will get developed. So the BMD will be like this. Maximum bending moment will be at support and zero bending moment at the free end. Okay, now here you can see that. Now read this statement. कोण वाचते सांगा, कोण तर वाचा एकदम. स्क्रीनवर दिलेला आहे. सिद्धांत पाटील. सिद्धांत पाटील. सिद्धांत शिंदे पाटील. तुकडे
Yes, sir.
वाचा, स्क्रीनवरचे स्टेटमेंट वाचा.
The negative sign in the formula applies when the bending moment mu increases numerically in the same direction as the effective depth d increases.
मग आता मला सांग, त्या फॉर्म्युलामध्ये पॉझिटिव्ह साईन वापरायचं का निगेटिव्ह साईन वापरायचं. परत एकदा स्टेटमेंट वाचून फिगर बघायची. कोणी सांगा जर कोणाला लक्षात आलं असेल तर. Negative sign in the formula applies when bending moment mu increases numerically in the same direction as the effective depth d increases. मी इथे पॉझिटिव्ह साईन वापरणार का निगेटिव्ह साईन वापरणार सांगा मला, कोणीही सांगा.
नेगेटिव्ह साइन वापर.
नेगेटिव्ह साइन.
अजून सगळं विचार करा. का बरं निगेटिव्ह, तर का आणखी जस्टिफाई युअर आन्सर.
बेंडिंग मोमेंट इन्क्रीज होते जसं जसं डेप्थ इन्क्रीज होते.
ठीक आहे, मीन्स that when you go from this free end to the support, this bending moment is going increasing. ठीक आहे, म्हणजे तुम्ही या डायरेक्शनला ज्यावेळेला याल, so from this point to this support the bending moment is increasing. Here the bending moment is 0 and here at this end it is maximum. If you see this, then at this free end the depth is minimum, and as you move in this direction, that is in the same direction as bending moment is increasing, the depth here at this end is more. Okay, so the statement here what they have mentioned here, that the bending moment mu increases numerically in the same direction as the effective depth d increases. म्हणजे इफेक्टिव्ह डेप्थ इथं या डायरेक्शन मध्ये वाढते, बेंडिंग मोमेंट पण सेम डायरेक्शन मध्ये वाढते. सो दॅट्स वाय In such cases, you have to consider the minus sign here. ठीक आहे, instead of plus here you have to consider the minus sign. इथे लक्षात आलं का?
Yes, sir.
हो सर.
Yes, sir.
ठीक आहे. Now again we'll consider one more example. आता ह्यातलं बीटा म्हणजे हे दिस अँगल मीन्स इन्क्लाइन पोर्शन आणि हॉरिझॉन्टल प्लेनशी जो अँगल आहे दॅट अँगल इज कॉल्ड एज अ बीटा हियर. ओके, नाउ वी विल कन्सिडर वन मोर एक्झाम्पल. This is a beam. Okay, this beam is again subjected to external load W. So this is simply supported beam, and here the bending moment diagram will be like this. So which sign you are going to use here? बघा असं एमसीक्यू असू शकते बरं का, एक्झाम मध्ये असं एमसीक्यू असू शकतो. So which sign we have to use here? Positive or negative?
पॉझिटिव्ह.
का?
बेंडिंग मुवमेंट डिक्रीज होते, त्याच डिरेक्शनला इफेक्टिव्ह डेप्थ इन्क्रीज होते.
ठीक आहे, म्हणजे एक्झाम्पल परत बघा. आता मी ह्या डायरेक्शनला जातो असं मी विचार केला. इथं पण इथं मॅक्सिमम डेप्थ आहे, आणि जसं जसं तुम्ही सेंटरला जाल तसं तसं मिनिमम डेप्थ आली इथं. आणि इथं बरं जर ह्या बेंडिंग मोमेंट डायग्रामला बघितलं, इथं मिनिमम किंवा झिरो बेंडिंग मोमेंट आहे. ऍज यू मूव्ह इन द सेम डायरेक्शन बेंडिंग मोमेंट गोज ऑन इन्क्रीजिंग. सो ऑपोजिट कंडिशन्स आहेत. ओके, so that's why we are saying here that the positive sign in the formula applies when bending moment mu decreases numerically in this direction as the effective depth d increases. म्हणजेच काय, बेंडिंग मोमेंट डिक्रीजेस ऍज डी इन्क्रीजेस. आता इथं बघा, तुम्ही इथून परत इकडे गेला, इथं डी कमी आहे, या एंडला डी सगळ्यात जास्त आहे, मॅक्सिमम आहे. And here bending moment mu here it is maximum, here at this point is 0. So as you move in this direction the bending moment goes on reducing, but at the same time as you move in this direction the depth goes on increasing. Same thing happens here in this direction. Okay, इथून तुम्ही बघितलं तर डेप्थ तिकडे हळूहळू वाढत गेले, आणि इथं बेंडिंग मोमेंट बघितलं तर मोमेंट हळूहळू कमी होत गेले. सो mu goes on reducing as d goes on increasing. So that's why in such cases you have to consider the negative sign. Okay, sorry, positive sign. So here the tau v should be like this: vu plus mu by d into tan beta upon b into d. या लक्षात आलं का?
हो सर.
Yes, sir.
नक्की सगळ्यांच्या?
Yes, sir.
आता एक एक्झाम्पल आहे तुमच्यासाठी. नाव कंडिशन अशी आहे, आता असं बीम आहे, here it is supported and it is subjected to UDL. आता इथं प्लस साइन असायला पाहिजे का मायनस साइन असायला पाहिजे? This angle is the beta. Again beam is simply supported. इथं प्लस साइन घेणार का मायनस साइन घेणार सांगा आता. BMD कसं असेल त्याचे? Simply supported beam subjected to uniformly distributed load.
पॉझिटिव्ह.
बघा, पॉझिटिव्ह कधी घ्यायचं आहे? ज्याला बेंडिंग मोमेंट डिक्रीज होते आणि डी इन्क्रीज होते. इथे काय होते? बेंडिंग मोमेंट डायग्राम विल बी अगेन parabolic. Here it is maximum at the midspan, and here also maximum depth is provided at the midspan. So
Yes, sir.
as you move from this suppose you are moving in this direction. Hmm? So bending moment goes on increasing, depth also goes on increasing. Or here you can take in this direction. Bending moment goes on reducing, depth is also going in the reducing up to the end. If you move in this direction, depth increasing. Again, if you move in this direction, bending moment is also increasing. मग कुठली साईन घ्यायची?
Negative.
सांगा बाकीचे. गिड्डे
Negative, sir.
गाडगे अंकिता माने अपसो.
Negative, sir. Negative.
So here you have to use minus आहे. ठीक आहे, ही पहिली केस आपली. ज्या बाजूला बेंडिंग मोमेंट वाढते तिकडे डेप्थ पण जास्त आहे. बेंडिंग मोमेंट इन्क्रीजेस न्यूमरिकली इन द सेम डायरेक्शन ॲज द इफेक्टिव्ह डेप्थ इन्क्रीजेस. ओके, सो हे कळलं का तुम्हाला की कधी मायनस साईन घ्यायचं आणि कधी प्लस साईन घ्यायचं?
Yes, sir.
अजून काही शंका आहे का? यामध्ये काही शंका आहे का इथंपर्यंतच्या पॉईंटवर? एनी डाऊट? आहे का? बघा टाइम संपलं आपलं. 1 तासाचं सेशन आहे आपलं आज. लागेल तर नाही, आज दुपारी नाही घेता येणार मला, कारण आज बीचे प्रेझेंटेशन्स आहेत. परत एकदा तुम्हाला सगळ्यांना सांगतो, कॉमन परत सगळेजण अवेलेबल आहेत म्हणून. तुमचं एमई म्हणतो टीवायचं मिनी प्रोजेक्ट जो आहे तो मिनी प्रोजेक्ट तुम्ही तुमच्या काय स्टेजला असेल, काय तुमचं प्रॉब्लेम स्टेटमेंट ठरलंय नाही ठरलंय, काय असेल ते तुम्ही तुमच्या गाईडशी डिस्कशन करा आजच्या आज. इमिजिएटली कॉन्टॅक्ट टू युअर गाईड टुडे ओनली. ठीक आहे. सो आय थिंक दॅट यू डोंट हॅव एनी डाऊट. सो थँक्यू फॉर अटेंडिंग दिस सेशन. आणि मी परवाच्या लेक्चरमध्ये तुम्हाला सांगितलं होतं की असाइनमेंट मी शेअर करीन. ते असाइनमेंट मी परवा शेअर केली नव्हती, तो आता इमिजिएटली थोड्या वेळात मी शेअर करतो. तर ते असाइनमेंट नंबर 2 तुम्हाला सबमिट करायचे आहे विदिन 1 वीक. ठीक आहे. सो along with that assignment again I'm going to share the notes also. पुढच्या पण नोट्स मी थोड्या आत्ताच टाकून ठेवतो. आणि जमलं तर 1-2 असाइनमेंटच्या पुढे सोडवायचे आपलं, त्या पण मी शेअर करतो. म्हणजे तुम्हाला थोडं जर लिहिता आलं तर तुम्ही लिहा, प्रयत्न करा. नाही आलं तरी काय अडचण नाही, आपण त्यावर डिस्कशन करू. Okay, so now you can enter your roll number into the chat box and then you can leave the meeting for the next lecture as per the schedule. Thank you. Have a good day. ठीक आहे, सगळ्यांनी रोल नंबर एंटर केले का? केले नसतील तर करा लवकर, मी मीटिंग एंड करणार आहे.